This is the notes for solving systems of equation by elimination. So elimination is another way to solve a system of equations algebraically. So I want you to think about, what does the word elimination mean? So it means for something to go away, for something to be gone. So when we eliminate in math, we can think of zeroing terms out. So when we have a 2 on one side and we want to get rid of it, we can subtract 2 because 2 minus 2 is 0. So that's what we're talking about in math when we talk about elimination. Specifically, I'm going to reveal this here for you. So what is elimination? It's a method for solving a system of equations by adding equations so that a variable eliminates. So I'm going to explain what it means to add equations. So make sure you write that down. And then we'll go into, what does that mean to add equations? So let's look at example 1. So example 1, 2x minus 3y equals 12 and x plus 3y equals 6. Okay, so I went ahead and set up the equations, the system of equations here again, and I want you to imagine that these are note cards, so I tried to make them look like little cards. So 2x minus 3y is equal to 12 and x plus 3y is equal to 6. Okay, I'm going to take out this bottom part here for a minute. So if I'm given an equation, remember that you can do anything you want as long as you do it to both sides. So if I wanted to, I could subtract 5 from both sides, and that would be fine. So I'd get 2x minus 3y minus 5, because none of those are like terms, equals 7. That's great. I mean, it's not really great because that didn't help anything, so there's no reason for me to do that, but I could do it and still have the same equation. It represents the same relationship. And you could do things like add 3y to both sides or subtract 2x from both sides. If you wanted to solve it for y, you'd subtract 2x from both sides and you could put it in slope-intercept form. Well, neither of those things are very helpful to me. Well, what if I were to add 6 to both sides? So you might be thinking, okay, that's not going to be helpful either. But I do want to show you something. So if I add 6 to both sides, we know that that's okay because 6 is equal to 6. So as long as you do it to both sides, you do the exact same thing. So I'm adding two things that are equal to both sides. That's okay because 6 is equal to 6. I can add 6 here and add 6 here. So if you look at our system of equations, though, I know that 6 is equal or is the same as this expression x plus 3y. So we can think of this like substitution. Wherever I see 6, I can replace it with x plus 3y because according to my system of equations, those two things are equal. So instead of adding 6 to the left side, I'm going to choose to add x plus 3y. So think of this like flipping the card over, like I did in class where I'd put the expressions on one on each side of the note card because they're the same thing. So flip it over and there's x plus 3y. I know that that's okay because x plus 3y is equal to 6. So while this might not look like I'm adding the same thing to both sides of this equation, so if we started with the blue equation, I add x plus 3y to the left side and 6 to the right side. That doesn't look like it's the same thing, but it is because we are told in our system of equations that those two things are equal. So they look different, but we actually are adding the same thing to both sides. So since we were given that they're equal, what we're doing here when we solve the system is adding the left side of the equation to the left side of the second equation, and the right side of the equation to the right side of the second equation. And again, that's okay because since these two expressions, x plus 3y and 6, are equal, you really are adding the same thing to both sides of the equation. So since these are equal, have equality, this is okay. That's why we can add left side to left side and right side to right side. So I wanted to illustrate that for you in that way so that you understood why we can even do this. So let's just keep working with these little note cards here. So we have our equal signs lined up, so this will be equal. And so we add left side to left side. So when we add these together, we can combine like terms. So 2x and x are like terms. So 2x plus x, remember that's just a 1x. That's 3x. And then negative 3y plus 3y are like terms, and hey, they actually zero out. They eliminate. That's the whole point of this method of solving a system of equations algebraically. We want to add so that one of the variables eliminates, and luckily, it happened. Equals on the other side, combine those like terms, is 18. And now we can finish solving like normal because we're down to an equation that only has one variable, so we can solve for it. So the rest of the steps to finish solving using elimination are actually the same as if we were solving using substitution. So the only thing that changed was the start, how we start the problem. So we're combining the equations a different way. When we use substitution, we were combining the equations by writing one of the equations in terms of the other one, so writing y equals or x equals, and then substituting into the other equation. So that was a way of combining them. This is a different way of combining them where you add the equations together. I'm going to go ahead and get rid of all of this, and we'll start with the equations actually over here. And real quick, we can go back up to the top and finish some notes out here. So after combining the equations, the rest is the same as solving using substitution. You will substitute the value of the first variable that you solve for into one of the original equations. It's really key that you put it into one of the original equations and solve for the second variable and check your answer using the other equation. Now, one thing before we go on that's really important here is to remember something when we're adding equations. So you're going to add with purpose. So what that means is, luckily down here, when we added these two equations, the negative 3y and 3y zeroed out. It eliminated. Well, what if that doesn't happen? What if this was negative 1y and 3y? What if we added them together and nothing eliminated? Then we can't use this method of elimination, or we have to do something else first, and that will come in next section and part of this section. But what I need you to recognize right away is whether or not something will eliminate. So you have to recognize if what we want to happen will happen or not. And if it won't happen, if nothing eliminates, we need to do something else first. So just make sure you're watching out for that. These first examples will always be set up really nicely for you so you don't have to do anything, but I don't want you to always think that's the case because usually it's not. So make sure you line up the equal sign. I talk about that. So adding left side to left side and right side to right side. And it would be nice if the like terms were on the same side of the equation. So if you're given an equation where, say, this y term was over here, so if you were given something like this, 2x equals 12 plus 3y, and then you were given that other equation like that, you could not add together the 3y and 3y. Even though they're like terms, they're on opposite sides of the equation. This is on the left side, these are on the left side. These are on the right side, this one's on the right side. So since this 3y is on the left side, this 3y is on the right side, you could not combine them. So we always want our equations to be nicely lined up, and usually in the same order too. Like it would be okay if this said 3y plus x. We would still be able to combine the negative 3y with the 3y if it was over here because they're both on the left side of the equation. But we really want it to line up nicely. The x's, the y's, and then the constant terms on the other side. And that's called standard form that I've touched on just a bit and something that you'll study a lot in algebra. And so I just have on that next line, so example x on the left side for both sides of the equations. And remember, you can eliminate either variable. So we'll have some problems for you where the y eliminates or where the x eliminates when you first add the equations together. Okay, now that we have a little better understanding of why we can do this and what we're doing, let's go ahead and go back and solve this problem. So for example 1, like I illustrated with the note cards, adding x plus 3y, so that's this left side of the equation here, is the same thing as adding 6 because they're equal. We know they're equal because that's what our original system of equations told us. Let's go ahead and number them. And what I like to do if they're set up really nicely and something's going to eliminate like it does here, I just add them right here. So I put a plus sign. Make sure you do put that plus sign because we're always going to add. We're never going to subtract. And then go ahead and add. So combine like terms, so all left side to left side. So 2x plus x gives us that 3x. Negative 3y plus 3y zeros out. And then line up your equal sign. 12 plus 6 is 18. Finish solving that. It's not too hard. Divide by 3. We get x is equal to 6. Now you get to pick either of the original equations to solve for the second variable, just like we did before when we solved using substitution. I'm going to go ahead and choose equation number 2. So x, instead of x, I write 6 because I know that's what x is equal to. And then plus 3y equals 6. So finish solving, we want to isolate the term with the variable, so get the 3y alone by getting rid of this 6 by subtracting 6 from both sides. And that zero's out there. We're left with 3y equals 0. Now don't let that scare you, okay? Still finish solving like you would be normally. So divide by 3 and 0 divided by 3. If you have no cookies and 3 friends, all your friends get no cookies. So y is equal to 0. Our final step is to check our answer, and since we already used equation number 2 to figure out the second variable, I know that the xy pair 6, 0 works in equation number 2, so I need to check to make sure it works in equation number 1. So make sure you check it in the correct equation. So 2, and then instead of x, we're going to put 6, and then minus 3 times our y, which is 0. And we want to make sure, is that really equal to 12? So order of operations, multiplication comes first. So 2 times 6 is 12. And then over here, 3 times 0 is 0, and we're subtracting that, so it's going to be minus 0. And 12 minus 0 is 12. So we know our answer is correct. So remember, we want to put our final answer as a coordinate point, so x comes first. So it's 6, 0, and we can use curly braces to indicate a solution set. And that's it. Thanks for watching.